Welcome to virtual spotlight on chemical and biochemical engineering. And so I'm a chair and professor of the Department of Chemical and Biochemical Engineering at Missouri SNT. And before I get started, I would like to introduce a panelist and who will join me in the Q&A session, and just in case you have questions so they can answer. In addition to myself and Dr. Christy Lukes, our Associate Chair for Undergrad Studies, Dr. Ji Qing Wang, our Graduate Coordinator, and Richard Balsall, the Member Academy of Chemical Engineer and Industrial Advisory Council. And also we have a students representative, a president of Student Advisory Council, Griffin Taki. And so let me give you, I know, so some of you are admitted to the program already, and some are not and still considering us. And so I would like to give you a very general view about the program, and also give the opportunity to learn so what we can do to the student success. And Missouri ST definitely is a great university for you to start with, and purchase for your college degrees in engineering. And so we are very proud and to be a top program overall in terms of the education in engineering. At the same time, so the best value investments is another proud uh, thing we are want to cheer for. And for those who have now been to Aurora, and so Missouri NST is located off Interstate 44 at exit 185. And also if you see my laser pointer, so that's where we are, Bertelsmeyer Hall. And Bertelsmeyer Hall is a relatively new building. So the completion of the building was in 2014. It has 68,000 square feet, houses a number of teaching and research labs. And so you can see on the right, and there's the UNAP lab. And so those are the major classrooms where students can gain their exponential learning. And for our departments, and we have currently 14 faculty members, and uh, so those faculty members are very scholarly active, and also they are excellent researchers in their field. And we have 8 full professors, 3 associate professors, and 3 assistant professors. And as students, and we have slightly over 300 undergrad students, and we have 42 doctoral students and 60 master students. And so the department offers uh, bachelor's degrees in chemical engineering, and also there's a biochemical engineer emphasis. We also offer a master's degree and a PhD degree as well. And also we have the certificates program, so that will give us students into pursue a very specialized bioprocess program in that area. Annually, there are over $100,000 scholarships that have been dedicated to our own undergrad students. And probably there are about 150 students receive the scholarship each year. Depends on their academic standing and also their financial need. So we've been doing very good in job placements, and there's a, a very high job placement rates in the past year that you can see. And in terms of top employers, and so Merck, so those are pharmaceutical companies, and all your companies are top employers. And also there's a lot of chemical companies, DuPont, uh, P&G, and so those are our top employers. The students always have the opportunity to get their co-op experience there, and the same time, so we have a very strong a network with them through our alumni. And so this slide you might be interested in learning. I just got this from a career office, and so this is a relatively new thing. And so you can see there's not all information provided here, but we are collecting this information for undergrad students. And so you can see this in terms of the base salary for the entry level. So there's a very competitive, and for masters, and also there's this very competitive as well. So although I don't see the number for doctoral average salary, but I expect that will be over $100,000. And so that's the information I want to share with you. And so our program provide a variety of activities, and so students can participate in undergrad research, internship, and design teams, and many other student organizations, and to gain their experiential learning, which is required for our program. And also that indicates why our students are so competitive uh, in those companies. And our AICG Chemi CAR team has been doing tremendously successful job and winning third place in national competition last year under guidance of Dr. Lukes. And so you can hear from her, and when she speak about the student success. And the last semester, we were fortunate to receive $10 million naming gifts from Linda and Bevan Doshi family. And so this is the single largest contribution to an academic program in the university history. So with these funds, we are looking for recruit new professors. And at the same time, we're going to use this fund to support students research activities and provide them seed funds. And so our goal is to increase undergrad and grad enrollments, provide funding for growth in new research area, and ultimately we want to raise the department national reputation. And they're not very unique program I want to highlight is this is student mentoring. So this is the program that's initiated by our alumni, and so they use this mentoring program to give student opportunity to learn how to speak effectively, how to build a strong network. And so we have the sessions twice a semester, and so students can participate in this program and learn their leadership and communication experience. And to the right, you can see there's the link, and also this article has been freely distributed. And so if you're interested in learning, reading this article, yeah, please contact me. So I'll be happy to share the copy with you. And also, I want to talk a little bit more about SAC, so Student Advisory Council. Our current president is Griffin Taki, and so this organization is standalone, and also the work with me and provide me the feedback from students, and at the same time, they work very closely with IAC and for mentoring program activities. And currently, they are working with IAC to get some a workshop related to Flash and Lean Six Sigma, and so that can address their future career need. And in terms of the area expertise, and so the department has a variety of research areas, including biomaterials and drug delivery. That's my area. Carbon capture, hydrogen storage, hybrid energy system, molecular simulation, process design modeling, multi-phase reactor engineering, and applications, and also surface chemistry and a nanocatalyst for various applications. So within those areas, I want to just give you a few highlights, and so that come from each professor, and so you know what they do, and also they have a very keen interest in having undergrad students work with them. Dr. Monday's research lab work on the chemistry and for sustainable infrastructure in energy and environment. And Dr. Liang is our mid-career professor. His expertise is surface science and surface functionalization. And so he use some very cool surface modification technologies and to make materials for energy storage, catalyst, and environmental remediation. And also we have Professor Angela Louis King. Her area interest is finding uh, hydrogen as alternative energy to decarbonize the society. And so that's one a big thing for us to do, to find a non-carbon based energy source and to make our environment green and to prevent a global warming. And Dr. Joseph Smith, and so he works on biofuel production, gas flaring, and so there's many other very interesting projects that are going in his lab. And so you can see from this scheme that, yeah, so he worked on the design and the bioreactor and plasma reactor, so on. And for myself, and so I'm interested in bio manufacturing and pharmaceutical engineering. And so I use polymer biomaterials into a design of various delivery systems and to deliver these all the drugs into the body to treat various disease, and for example glaucoma and cancer therapy and cardiovascular diseases. And so students all in even in their first years do have a chance, and so they're always welcome to join my lab and build a partnership with my graduate students, and then join those ongoing very exciting research field, and then gain their research experience in nanomedicine and the drug delivery. And Dr. Wang and is the expert in modeling, and so he deal with the simulation to understand the molecule transport, and also the interaction with the biomolecules at the interface phenomena. And I think, yeah, I just want to stop here and uh, to give you the opportunity to ask us questions. And also, yeah, I have Dr. Wang, Dr. Lukes, and Richard Balso and Griffin here. So I would like uh, you to hear from them directly. Thank you very much.
Would each of the panelists mind just introducing themselves again really quickly? And Dr. Lukes, because I see you, I'll start with you.
I am Christy Lukes. I am the associate chair of the department and primarily deal with undergraduate, I don't know, courses, advising, whatever. And then I teach a lot of courses also. So design, lab, thermo, kind of a little bit of everything.
Right from the screen, Juqing Wang. I joined the department in 2000, new millennium. Associate professor, currently serving as a graduate coordinator. Yeah, I also have been teaching a number of courses in the department, mostly required courses. Appear to me that currently the main focus of my teaching efforts has been on thermodynamics, from thermal 1, thermal 2, intermediate thermal to advanced thermal. I have the department take care of our graduate students. Thank you.
Griffin, we'll go to you next.
All right, so I'm Griffin Talkie. I am a senior here in the department. I will graduate next fall with a Bachelor's of Science in Chemical Engineering. And I'd just like to highlight that I am the person to talk to if you have questions on co-ops and internships, because I have done both of those. Thank you.
Good to be with you all. My background is primarily been focused on the mentoring program within the department. We developed a mentoring program for our students over a period of about 6 years. It's very effective. Really gives the students a leg up, a jump, and a head start as they move on into the workforce in their careers. So it's an opportunity for them to interface with a number of industrial staff that have spent years in their career. And that includes everything from oil and gas to chemicals to utilities, and then many others as well. So the program itself is really focused on providing the kind of information that the new student moving into the workforce is going to be tasked with. That includes issues like leadership, communication, networking, negotiating skills, and that's what the mentoring program really focuses on. I'm joined by a group of about 10 different mentors working with Griffin and others that, along with the head of our Industrial Advisory Council, in putting this program together. So it's great to be with you tonight. Thank you.
All right, so we've already got some questions coming through. I'll start with the first one, just in case it wasn't answered during the presentation. Is biomaterials and drug delivery similar to toxicology?
Yeah, I guess that question is for me. They're now the same or similar. However, the toxicology will be used as a tool to assess the cytocompatibility of the materials that we use in the body. And the biomaterial and drug delivery is the interdisciplinary area that focuses on the material developments and also the engineering and the medicine. So that's very broad and truly interdisciplinary.
Next question is, and this is a good one, I've heard it asked before too, is can you talk about the differences or similarities between chemistry and chemical engineering?
Dr. Lukes?
Why don't I start, and maybe Ji-Ching or Griffin maybe take it next. So kind of in general, chemical engineering is, historically it was a blend of chemistry and mechanical engineering. These days we've actually added a lot more biology to it, and there are a few other things that we do. But so our students are going to be taking courses that are strong elements of both. If you earn a degree, a bachelor's degree in chemical engineering, you're one course short of a minor in chemistry. So a large number of our students just go ahead and take that one course and get the minor. Yeah, that's probably the main thing. So when I describe what's the difference between chemistry and chemical engineering, chemists are looking at the microscopic level, or they get really excited if they create a beaker full of stuff. And then they bring it to the chemical engineer and say, can you make money off of this? And we have to design how on earth you could make vats and vats of this. And that's kind of broad stroke differences between the two. Griffin, Ji-Ching, actually any of you, but I suspect you have strong feelings.
Well, I can also share some facts that can tell some major differences between chemistry as a degree program and chemical engineering as a degree program. We require our students to finish 129 hours, total number of credit hours to graduate, out of which less than 20 are the number of hours directly from chemistry courses. So there is from those two numbers alone, you can tell that there are big differences. And from a more general point of view, I would categorize chemistry more on the science side. Science is more about knowledge, about discovery. Chemical engineering is on the side of application. Engineering is about application of science and about product. And we are specifically about the process that built around chemical conversion to produce desirable product from different raw materials. And one example that I tend to give to my students is that when you are thirsty, you don't want a recipe to purify water. You want bottled water directly drinkable. And the recipe to tell people how to purify water from whatever source, that's knowledge, that's discovery, that's more on the science side. But if you want purified bottled water directly drinkable, that's more on the engineering side. That's our expertise. So, Griffin?
Yeah, I think Dr. Wang, you hit that pretty well. I will say from my personal experiences, my co-op was in brewing, and so basically daily we took our chemists, reports, especially on certain chemicals, and then you can apply those. So it's definitely heavy applications, not necessarily the actual, running the GC spec. It's more of getting those readouts and then knowing how to extrapolate that results into your process.
Oh, I want to add one thing that will make Griffin very happy. That is, there's also a very big difference between salaries, career earnings. Yeah. See, so he's smiling and nodding his head. Mm-hmm.
Griffin, I'll ask you a follow-up question because you had mentioned that you've done a co-op and an internship. So I was wanting to see if you could talk about who you co-opted and interned with and kind of what you did. And then real quick, just so everyone's aware, an internship is typically done over the summer. So it's about 2 or 3 months long, but a co-op, it's a little bit longer. So it's usually a year semester plus a summer. You're looking more at 8 to 9 months. So I'll let you, Griffin, take it from here.
Yeah, absolutely. So I've co-opted and interned. My only co-op and internship with Anheuser-Busch, both experiences. My co-op was in their innovations lab, brewing, the next big kind of project. And so that was really interesting because dealing with daily trade secrets and a lot of non-disclosure agreements. So it was kind of cool to be a 21-year-old college student and being able to go home and tell people I can't talk about it. And then my internship over the summer of 2020 was at Anheuser-Busch's Metal Container Corporation, doing a lot of utilities work, really implementing kind of the utility process side of chemical engineering into our air dryer units, and scaling those up, and on top of that, managing some operators on the side. I do have an internship with them this upcoming summer. I do not know where and what I will be doing, but I do know that I will be there this summer.
All right, thank you, Griffin. So going back to the questions that we've got, next question is, can you name specific opportunities for students to do undergraduate research And then there was also a, could you name opportunities about studying abroad?
Dr. Lukes?
So I think I'll answer more on the study abroad part. Undergrad research, I promise you, all our faculty want you to do research with them. They love having undergraduates work with them. Just ask. I've never known any student that wanted to do research that ever got turned down. The faculty love working with undergraduates on research. As far as study abroad, so some of our programs are, we do have some students who go through a formal study abroad and they'll go do a semester at another university. It's a little easier to do that kind of early in your career simply because the curriculum is very specific and it's hard to find another program that's going to match very well. A lot of our students, if you look at the background behind me here, this is Bolivia. I work with Engineers Without Borders, and we actually have a new and improved program to help students find internships. And actually my projects in Bolivia and Ecuador, we are looking at turning some of those into internships that you would do a summer working in one of these countries and then get a special certificate along with your degree. We also have a minor program that you could do that way. But there are a lot of opportunities like that. Again, I work with Engineers Without Borders. That's not the only way to do this. But you get to, with my program, okay, with our program, you get real practical engineering experience. So we have one program where they are, right now, they are building a school. Now we are supervising from here because we can't travel, but we are literally building a school for 300 children in Guatemala. And then we will be building all of the water systems for hygiene purposes that are going to go along with that school. And so the students actually did 100% of the design. My project in Ecuador, it is a very, very remote rural location. And so we are finding water sources that are clean enough and then cleaning the water that's dirty so that we can provide drinking water to every home. And the mountains in Bolivia that you see here, there's actually a glacier. If you go up back around behind that mountain there, there's a glacier back there, and we are taking glacial melt and capturing it and bringing it down to the community so they will have water. So yeah, so there are lots of opportunities for doing engineering that have some of that global feel to it, but you can also then travel with EWB, or you can travel and do global internships, and we have those as options, or just normal study abroad.
Right, I would like to speak a little bit more about the undergrad research. And so in addition to the slides I show you at the end, so those are the faculty who are interested in recruiting students. Like Dr. Luz mentioned, actually all our faculty members are keen to have undergrad student work in the lab, and you don't necessarily wait until you are reached the senior level. And in fact, if you're interested, you can join on day one on campus, and so that gave you the great exposure to research. I always have undergrads in the past who work with me for a few years, and they co-published the papers, and so that will help them really well prepared for their graduate school.
As a quick follow-up, Dr. Yang, someone asked, can you talk about what role an undergraduate student plays when they are actually assisting with research or in the laboratory?
So I treat each undergrad students equally and fairly. And initially, I would like them to partner with my senior student, grad students, and so they can learn from them and get all the technical skills And later, so if they're very confident, interest in exploring some other area projects, and so I would like them to do as well, so that they can be very independent and lead the projects, and so that there's various roles they can play in the lab. And what about Dr. Wang? So do you have experience with your working with undergrad students, and how you perceive those undergrad students?
Yeah, I think between you and Christy, you have described very well the things that undergraduate students can do in various professor groups. And my research projects are computational. It seemed to me that nowadays the students are less interested in computational type of projects, and more interested in bio experimental type of projects. So I used to have undergraduate students working with me. Sometimes they also help me transform some of my research project and results into educational modules to be included in my classes. In recent years, I'm not as lucky as before. But I want to mention this, that we do have undergraduate students. We do like our undergraduate students very much. And we also like them to continue on to be our graduate students. So we have professors recruiting and being able to convince our undergraduate students to pursue PhD degrees in the department. I'm in position to also help them process applications and admit them into our PhD program.
Right, Dr. Wang, can you, you just mentioned these points. Can you talk a little bit about our grad track?
Oh yeah, of course. About two years ago, but less than 2 years ago, in order to encourage undergraduate students, especially senior students, to continue on if they have strong interest in research or advanced degrees, we have a dual enrollment opportunity on campus in our department. And so basically, a senior student can apply and then be admitted into our master program through the new dual enrollment program called Graduate Track Pathway. And this program allows undergraduate students to have their senior elective courses to be also counted towards their advanced degrees. In other words, it's like one stone, two birds kind of deal. And if a student pursuing a non-thesis degree, this program can save at least one semester out of their pursuit of their master degree. If a student wanted to continue on into PhD program and so on and so forth, this also pays them very well and can expedite their graduate studies. At this point in time, we have 3 students pursuing their master degrees through this program. And the first one happened to be my advisee. She will be finishing her master degree in fall this year.
Thank you, Dr. Wang. And also, I want to mention the Commerce Institute. And so there's a new opportunities for prospective students. So that's called the Vanguard program. And so I just want to draw your attention to this program. So last year, so the university have received $300 million and to create the Commerce Institute. And so students are available, are allowed to join this program, and so they can learn entrepreneurship and innovation, and through this Commerce Institute.
Can I quickly add one thing?
Yes.
Commerce Institute also offers fellowship to undergraduate students.
Yeah.
So I know as a matter of fact, not only from the website, but also that one of the high school classmates of my son, senior student in Raleigh High School, he applied and was offered Commerce Fellowship, which would financially sponsor him in the amount of $3,000 to $5,000 a year.
Thank you.
Yeah,
Back
thank
to
you.
Tyler.
Thank you. So before we move on from that question of undergrad research opportunities or study abroad, I did want to share one more thing related to the study abroad aspect that you could look at doing, and that's the new global engineering program. Global engineering just started in the fall of 2020, but it gives you the opportunity to earn 2 degrees over the course of 5 years. One of the degrees is engineering, so it could be chemical engineering. Your second degree is in multidisciplinary studies. And as of now, for the scope of global engineering, we're limiting the language options just to French or Spanish. The really cool part about doing the global engineering program, though, is that that 4th year, you're spending entirely overseas. So you're getting a chance to do a semester of study abroad, plus you get to do an engineering internship abroad. So this is a great opportunity for you to really hone in on that foreign language skill, immerse yourself in the culture, but then you also get some work experience while you would be doing that. So if you've got any more, if you would like any more information on that program, you can check out their site at globalengineering.mst.edu. All right, so the next question that we have is, can you talk about if chemical engineering is a good degree program for those interested in going into drug research or drug creation?
So if I understand correctly, drug creation research mainly, so I think there are two distinct areas. One is called medicinal chemistry. So that's exclusively focused on a small molecule drug design, molecule synthesis. And for chemical engineering, and so if we do drug delivery, so our goal is to make the current drug work better, and so that we can increase their half-life and increase their water solubility. And even for a cancer therapy, we can make them into a nano targeted formulations and to reduce the systemic toxicity and also increase the potency. So there are a lot of things chemical engineer can do with drugs. And also I hope I answered the question.
Can I also add one more aspect?
Yes.
On the production side, again, we call it bioseparations, because the biomolecules as therapeutics, when they are produced, they are not produced in pure forms. They are produced in a mixture form together with many other things, including impurities. The government regulations or the demands of customers, including ourselves, right? We want those therapeutic biomolecules to be in precise and pure forms. So they had to undergo a long trend of separations. And this is where we chemical engineers can apply our expertise to help carry out bioseparations in a very effective and efficient way. So I would like to add, this to Dr. Yang's great answer.
Thank you.
Yeah, thanks.
All right, panelists, thank you so much. Are there any final topics or any final comments that you'd like to share with our participants?
First of all, I want to thank you all for attending today's virtual spotlight on chemical and biochemical engineering program. And really, that shows that you're serious about our program. And so I welcome you to visit us. And so we're here, and so we can arrange in-person open house and or discovery day. Or if you feel more comfortable joining us while a Zoom, so we can arrange that too. So come with us, and so we're here answering questions. And also I want to point out that we have really strong support from our alumni like Richard Balso. So he and other academy and IC members, they made themselves available to our students, and so they are genuinely interested in helping students to succeed in their career.
I'd like to comment on that too, if I could.
Yes, please.
Okay. Yes, Dr. Young. Yes, the academy members and advisory council members really take the approach of putting our arm around students, giving them a hand, providing them some, what I would call background and industrial wisdom about what their career might look like. I would say that this degree, the chemical engineering degree, is probably one of the most, if not the most versatile degrees in all of industry. Quite frankly, I'm a bit biased here, but there's really nothing that a chemical engineer cannot do, quite frankly, whether it's finance, whether it's pure engineering, whether it's research, whether it's operations, whether it's production, oil and gas, or chemicals, or manufacturing. Your career opportunities are exceptional with this degree. So, and I'm just looking, Dr. Young, at the key hiring companies you mentioned here. I'm looking at Merck and Exxon and P&G, Dow, BASF, and others. These are both domestic and international firms. These are our key, and there's many more, hiring companies. So we're looking at, with our campus, at some of the most significant industrial organizations in the world, quite frankly, that we have reputations with. So there's a great opportunity for growth and development and just career guidance and direction. So I think you'll find, if you decide to choose MS&T, you're going to find a number of industrial staff that have significant backgrounds in industry that'll come alongside you, help you, guide you, act as an advisor as well, including your student advisor that'll be right there alongside with you. So I just wanted to give you a little flavor for that too, Dr. Young, and the students. Thank you.
Thank you, Richard. Thank you.
All right, thank you again, panelists. That is all that we have for this presentation and Q&A. Hope you all had a wonderful time listening to more information about the Chemical Engineering Department. And if you do have any more information, you are more than welcome to reach out to the department, or if you want to reach out to admissions, you can likewise do that.